Graphing rational functions, we need to be aware of a few things. The main things for now, anyways, are we want to find the zeros, we want to find vertical and horizontal asymptotes, any holes, and for now we want the y-intercept. So the first thing is we're just going to look for the vertical asymptote. And the vertical asymptote is probably the easiest thing because it's when the denominator is equal to 0. So we have vertical asymptote at y or x equals -2. Okay, so I'm going to draw my vertical asymptote here. Horizontal asymptotes are going to occur where when x is really big. What's happening to this expression is when x is large, the -1 and +2 essentially are insignificant. So we end up with x over x. So we end up with a horizontal asymptote. X over x simplifies to just 1. And we end up with a horizontal asymptote at x equals 1, or y equals 1. Okay, so x equals -2 here. We should write in a few coordinates here. So 0. The 0 is going to happen at +1, and we're going to have a y-intercept at -1/2. Okay, there's no holes here, so to draw this in, essentially it's just going to look like this, through there. Okay, and we don't have any coordinates on this side, so we can just kind of draw it. If you want some coordinates, you can make a table of values. You can make a table of values here. And this is not entirely necessary, but we can put a coordinate in at -3. And x equals +4, it looks like. -3, yeah, it's going to be equal to +4. Okay, and then we can draw in a coordinate here. Okay, so we end up with another graph here. Okay, so vertical asymptotes. Vertical asymptotes are going to be at -1 and +5. Okay, as x gets large, what's going to happen is these terms are going to become insignificant. So we're going to end up x squared on top, x squared on bottom. So again, the horizontal asymptote works out to be +1. Okay, so vertical and horizontal asymptotes, I'm going to end up with x-intercepts at 3, and it looks like there's one at -2 as well. The y-intercept is when we plug in 0, so we end up with -6 over -5. So the y-intercept looks like it's going to be -6 over 5. So maybe somewhere about there. Okay. And there's no holes in here. Now, again, if you want some coordinates to be able to draw this in, okay, this is going to be, we want to be able to draw the coordinate. We can put some more coordinates by making a table of values. In this case here, we should probably just we can just use the patterning. So, looks like the graph's going to go like this. And I notice that this point I think is off. I better double check that point. So this was -6 divided by -5. That should have been +5 over 6 over 5. So it should have been up here like that. Okay, that makes more sense because usually what's going to happen is as the asymptote goes down this way, it should start on the opposite side up here. Okay, so it's going to go through there, going to go through 0, and it's going to go down the asymptote like that. Now, one thing that's important to understand is that vertical asymptotes we can't cross. However, horizontal asymptotes, no problem. You can cross horizontal asymptotes. They're not restricted values for y. Okay, they're just what's happening as what we call endpoint behavior. They only tell us what's happening way out here and way out here. It doesn't tell us anything about what's happening inside here. Okay, so the horizontal asymptotes, there's no problem crossing those horizontal asymptotes. We can flip across the other asymptote, vertical asymptote though, and it should flip to the other side, and it's going to just follow the asymptotes like this. Again, if you want a more detailed graph, you would just plug in some coordinates and make a table of values. So this one here, this one has a numerator that's 1 greater than the denominator. that means we're going to end up with a slant asymptote. And we're going to find that slant asymptote from long division. So first of all, let's work out the vertical asymptote. Okay, so that's my local behavior. I want to find my slant asymptote by dividing. So I get x minus 1 2x squared plus 5x plus 3. Okay, so that's going to be 2x. That's going to be minus 2x. So we end up with 7x when we subtract that, plus 3. So I get with plus 7. So I end up with 7x minus 7, and I get a remainder of 10. Okay, so that remainder actually does tell us something, but it doesn't really, it's kind of redundant information. So that becomes my slant asymptote. I've got a slant asymptote at 1, 2, 3, 4, 5, 6, 7. Okay, it's got a slope of 2, so it's going to look like that. Okay, I want to now factor to get my zeros. Okay, factoring this, I end up with y equals 2x plus 3, x plus 1, all over x minus 1. So I have a 0 at 1, negative 1. I have a 0 at negative 1.5. So right there, oh, those are really close together. So it's almost basically touching there. It's going to follow the asymptote here like this. It's going to touch and then come down. I should find out my y-intercept. My y-intercept looks like it's going to be negative 3. Okay, so it's going to cross at negative 3. And then it's going to go down like that. So I have no points on this side. And again, I'm not looking for much detail, but just understand that it's going to be across this diagonal. So we should have a graph that looks like that.